We're standing here next to Tryon Creek, below Oregon Highway 43 and Lake Oswego. A short distance to my east is the confluence of Tryon Creek with the Willamette River. Project behind me was to improve fish passage through Tryon Creek. By way of a little bit of background, historically salmon, trout, lamprey were resident throughout Tryon Creek. However, as the Tryon Creek watershed developed, urbanized, increased runoff, leading to increased discharge of water in Tryon Creek, leading to a down cutting of the stream channel below the concrete culvert that carries Tryon Creek underneath Highway 43. That down cutting created a jump or a gap to where fish could not migrate up into the culvert. Additionally, even though this culvert, built in the 1930s, had an early generation fish baffles, the length of the culvert, approximately 400 feet, and a relatively steep grade of the culvert, varying from 3% to 6%, made it very difficult for those fish that got into the culvert to be able to migrate all the way through the culvert to get up into Tryon Creek State Park to the west, and then ultimately into the upper watershed. Recognizing these obstacles to fish passage, a multi-agency, multidisciplinary team came together, several on-site discussions, several in conceptual design type meetings. We collectively concluded that it was feasible to raise the water elevation in the stream channel by regrading that channel, eliminating the jump barrier of getting into the culvert. And we also concluded that replacing the older generation baffles with a more effective one would provide better refuge for migrating fish to be able to get through the culvert. That led to a project that the Oregon Department of Transportation District 2A crews accomplished under the guidance of the City of Portland, Bureau of Environmental Services, and their consultant, to strategically place rock and tree logs to raise the water elevation and to create a low flow channel to allow fish to migrate up into the culvert. The baffles were also replaced at that time, leading to a much easier task for fish to migrate through. Work was done in July of 2008 and completed in approximately 3 weeks. Design, construction, oversight, we spent approximately $225,000 on this effort. Some months later, and specifically New Year's Day 2009, a very heavy rain event tested the adequacy of our design. What is a normal flow that you're looking at here, something in the 20 cubic feet per second range. January 1st, the flow increased to 530 cubic feet per second. I'm pleased to say that that which was done in channel modifications remained intact with only minor disturbance.
This project, as Ron said, is one of those projects that we have been working on, actually looking into implementing and putting in the ground for quite a while, and we are pleased that it finally got in the ground and got constructed. Highway 43, in our assessment, by our I mean City of Portland Environmental Services, has been identified as a key obstacle to fish movement, up into the Tryon Creek system. This culvert really in this location is at the very downstream of the watershed, and all of the good habitat and spawning areas are above the Highway 43 culvert, obviously within the Tryon Creek State Natural Area, and then up above all the way through where I-5 crosses, the very headwaters of Tryon Creek.
I'm Mike Gehring, District 2A Bridge Maintenance Supervisor, along with the ball dock maintenance crew. We teamed up and did the work on this stream enhancement project. Here, the biologists and one of the Region 1 environmental coordinators is removing fish, placing a net on the upstream side of the creek before the work zone. Here's the downstream side. They're going through with a net trying to get fish out of the collection pond. This is one of the bridge crew guys, Craig. He's placing anchors in the culvert wall so we can put a diversion dam up. We're going to stop the water and dry the stream bed. This piece that we're floating in is 2 pieces of 1 1/8" plywood laminated together. The black pipe is a piece of ABS that's mounted in that plywood. You can see it's mounted high enough so that we can dam the water up in the culvert high enough to get it through the work zone where the maintenance crew will be having their equipment down there. We place that in. Now we're using a dry pack, water patch, mortar mix to stop any of the leaks. That white valve that you see up there, that will be for drainage purposes, and we also thought that if they needed any water to water down the stream bed, that might be a good source to get it, but that's for drainage. Here we're using more ABS pipe and unistrut that we just built a frame out of. And the unistrut's just sitting on the stream bed. We had to leave it up high enough to get completely through the work zone. It had to maintain a fall so that the water would run out of the pipe and not collect. And so we had to have it a couple feet up in the air to get through. Plus they're raising the stream bed 2 feet, and we needed to be able to keep the pipe over the stream bed so they'd have room to get the equipment and the rock in underneath to eventually raise the stream bed. So as you can see here, there's a lot of manual labor that had to go into it. Guys on the bridge crew worked pretty hard getting these in. We held them together thinking it wouldn't be under any pressure, but we wrapped straps around it, wrapped slings around it, and used the straps to hold the pipe together. We thought that might help just in case it were to get bumped or any kind of movement might occur while they were doing the stream bed work. So kind of tried to strap it all together, keep it from coming apart and washing out any of the work that they'd already done. That's an engineered stick we're using there to raise that pipe, so there's no chance that it'll break. This is just more of the unistrut that goes together. Electricians use this stuff a lot for hanging conduit, and for our purposes it worked out really well. It was adjustable, had lots of holes in it, we could make it fit to wherever we needed. Yeah, there you can see the finished height as it comes out of the culvert. Starts heading downstream. Because you can see the main channel there where everybody's standing, that's mostly where the work was going to be. We had to angle the pipe over to the bank so that we could keep it far enough out of the way of the work zone so that they would be able to get their track hoe and equipment in there and have plenty of room to work. Here the stream takes a dog leg to the right, so we had to put a 45 in the pipe to get around the corner and keep it flowing. There was another collection pond just down from the rocks a ways. They wanted us to try to keep as much water in there as we could in case there was any fish in it. So here, after we were de-watered, biologists came in one more time and just collected any fish or lamprey out of the last of the collection pond.
I'm John Bailey with the Baldock maintenance crew. We're part of the excavation on this stream, Tryon Creek. At any period of time, we had anywhere from 4 to 6 guys on the job. It took us roughly, the actual in-water work, we were in there for a little bit over a week to get everything completed and stuff. We probably had roughly a couple months of work into it though, for ordering rock and all the product. At this point, we are drilling logs, coring through the logs, and then we also drill into the rocks and put an epoxy into the rock to hold the logs to the rock with an all thread. Countersink the all thread in, try to keep the all thread from sticking out of the logs. Here's part of the epoxy process. We're epoxying the all thread and also epoxying in the rocks and logs too. Reason for epoxying the logs to the rocks were to keep them held so they wouldn't wash away. In this process, we used a total of 24 logs, roughly 18 inches to 2 foot in diameter. Some of the logs got actual epoxy and drilled into the base of the creek was solid rock in some areas, so some of them actually got epoxy to the creek bed. In this process here, we're placing boulders. This is real tight area conditions. Took some time to work around some of the pipe and tight shoulders in the creek or banks. We had water continuously running through the pipe, so you couldn't burst the pipe, otherwise you'd have water all over the place. The creek was running through the pipe. This is river rock on the top. We were putting on a top coat and building a channel at this time, trying to keep a channel for the fish. Roughly, we used about 350 ton of rock. This is the face of the area where we started working. We did roughly 100 feet of the stream. Some more placing boulders strategically, try to maintain rapids and stuff when the water's at higher levels. This is a staging area where we mixed rock and had boulders and logs sitting in a staging area and bring down into the creek area. We had the area covered with bio bags and wattles through the area to keep any excess dirt from the upper area to getting into the creek. Also, all the equipment that were in the creek had vegetable oils in them, so that if anything was to happen, it would be a vegetable oil solution. Here we're watering down the rock to get a compaction out of the rock so it doesn't wash away as easy. This is where we're using a pump to pump the water, so we're using creek water to compact the bed of the creek.
Then here was just the reverse process of taking all the pipe out and restoring the channel back to its new course. Now here the sandbags and all the grout comes out, and we start removing the dam. There's the finished product. This was the last phase of the project, was to remove the old outdated fish weirs and install some new ones. These were put in originally with stainless steel bolts, so believe it or not, they came out fairly easily. It was just a lot of water, and as you can see, we raised the water level so that drop off at the end of the culvert is not there anymore. But being a 400-foot culvert and having to haul those out by wheelbarrow or by come along was a pretty tough project. Was some drift still in there. It gets quite a bit of drift built up during the winter time, so we had to remove some of that before we could get them cleaned out. And a lot of boulders, a lot of rocks. Here we use sandbags to de-water the area enough to be able to get a torch in and burn the heads of the bolts off. It was becoming too time consuming to try to unscrew each one of them, so it was much faster to cut them. We had the electricians come in and wire up a drop cord for us and make sure that everything was grounded as we were working in the water, so wanted to make sure that we were safe. There's just some more torch work trying to get the old weirs out. See the sandbags there to de-water it. Now here's the new weirs that are going in. They're a plastic model. We're just laying out where we're going to bolt them in. You see they're taller on the sides, and they got those are 12-inch on the sides and an 8-inch piece in the middle. That allows for better flow for the water to come through and gives a resting point for the fish. And there you can see how it works right there. And they bolt together, leaves a nice little channel down the middle. And we just came in with a roto hammer and again stainless anchors, and just anchor them to the bottom of the culvert. And they were spaced out depending on the drop of the culvert. The steeper 6% grade, they were spaced closer together to slow the flow down, and then as we got farther down culvert, where it flattened out a little, the weirs became farther spaced apart. We pre-cut most of the weirs to the correct angle, as you see there, the bevel on the bottom of the culvert. They didn't always fit well. Once in a while we had to trim them a little bit. I'll blame that on the guys that poured the culvert in the first place. It must have been the bottom that was out of true. The culvert was approximately 400 feet long, so it was a pretty time-consuming project. Here's what it looks like, water flow without the weirs. And here's the finished product. Made a nice collection area for the fish to rest in as they're moving upstream. The water level is deep enough, they should be able to move well. Looks like it worked out pretty good. So here it is, the finished product. You see we've got the stream beds done. The water level has raised at the outfall of the culvert, so there's no problem for the fish to get through.
I'm Melissa Hogan, our Region Environmental Coordinator for ODOT. If I had to sum this project up in one word, it would be partnerships, hands down. It wasn't just that partners were willing to come to the table for this project, it was that every partner had something to bring to the table.
I would be remiss if I did not thank all the participating agencies that made this happen. Most importantly, the City of Portland, Bureau of Environmental Services, that provided much of the funding and the design for the stream channel modifications. Other agencies that played a very direct and positive role, the City of Lake Oswego, the Tryon Creek State Park, Tryon Creek Watershed Council, the Friends of Tryon Creek State Park, Oregon Department of Fish and Wildlife, U.S. Department of Fish and Wildlife, NOAA Fisheries, and Metro. So in summary, this challenging, beneficial, and fun project clearly demonstrates that governmental agencies can come together, work together to improve the aquatic environment.